Well, hello and welcome YouTube. Mr. Robinson here, and whoa, that actually really shows up a lot. I've worn a hat all day. Sorry for the hat line. Hey, this is a brand new video series that I'm going to try and do. If YouTube commenters ask some certain questions, this is going to be something called Ask Mr. Robinson. Now, I have another video series called Mr. Robinson Q&A Power Hour, and that's more for my students to submit questions, not really on solving a problem because I'm doing all the problems for them all the time, right? I do solution guide videos for all those things, but they ask more so generic questions on things. But a YouTuber asked a very specific question on how to solve a certain problem, and instead of typing it out, because I've done that before, people have asked questions and I type it out, and it's hard to type math stuff, and even when I explain it, I can't guarantee it's a great explanation, and at the same time, I don't know, they generally don't follow up in some sort of way, but I saw a problem here, and I thought, I don't know if I can explain it by typing it, so I thought I'd actually do this one for them. They don't know this is happening, and this might even be a couple days late. I remember when I saw it, said I wanted to make the video. This is my first opportunity to do so, so I'm going to do it for this person, and that person is user AXG005 asking, hey teacher, how can I do this question? Find the equation of circle which passes through the points 0, -3, and 4, 0, and whose center lies on the line x plus y equals 0. So this is not related to any of my current video series items here. However, I believe if you're following my Big Ideas Math Integrated Math 2 textbook stuff, this will fall into play in chapter 10. In our next chapter, I think in chapter 10, we started doing lines in the coordinate plane. I've never seen a question like this one before, so it's kind of interesting, the specific way that they're asking you to do the things here. So here's what's going on, and I'm going to do a generic, rough sketch version of a graph to make most sense of what it is. Instead of being specific to it, I just want to get a different one, because we're going to solve this algebraically. There's a point that's 0, -3, something like this. We're going to call that one P1. So that's 0, -3. And there's another point, is a different color here, P2, and we'll call that guy 4, 0. Somewhere a circle can be built with these 2 points on it. Actually, there may be more than one, but there's also the line, I forgot about this, there's also the line x plus y equals 0. Let's see that. X plus y equals 0. If I write that in like slope-intercept form, that's y equals -x, which is y equals -1x plus 0. And I bring that up just to get you the idea of what that graph would look like. I don't know if we need the drawing itself as much as anything else, but I am going to go and place it on here. This would kind of look like this. It has a slope of -1, like that, and then it crosses through the origin. Now, what I want to do with this is kind of give the idea of somewhere on here, a circle is drawn with its center on here. Could it fit like that? Maybe. It doesn't really look like, it's not drawn to scale. I don't know. Like that? See, you could probably hit like that. Maybe there's a center down there. I don't know for sure. We're going to just pretend like there's a center down there like that. And we got to find out what that center is, because they asked to write the equation of a circle with this. Now, the equation of a circle, if the center is at some hk, like that, the equation of the circle looks like x minus h quantity squared plus y minus k quantity squared equals r squared. Our goal is to determine what that center is and what that radius is. Now, a circle, by definition, is a set of points that are all equidistant from that center, and that distance is the radius. Therefore, if these are 2 points that are on, and this is just a made-up drawing. I don't know if this is where the center is at all. I haven't done the problem yet, but I said I want to make a video out of it. But if the radius is, if these are 2 points that are on the circle like this, then that means that this would be the radius and this would be the radius. Case in point, these are the same distance away. These two are equal. So my idea of this problem that I want to do is I want to find some xy value, or some hk, whatever you want to call it. I want to find some center point that's the same distance away from these 2 points that's on the equation x plus y equals 0, or y equals -x. Now, if there's any point, instead of putting hk here, I'm going to take advantage of this part here. If y equals -x, then any xy point on here, I don't need to call xy, I can call it x -x, because y equals -x. Now, why might I want to do that? Because I need to get as many things in terms of one variable as possible. If I can get all things with x in them, then I can go, because these are going to be numbers, right? This is going to be numbers, this is going to be numbers. If I can get all things with one variable in it, then I can solve for that one variable, And then the y value will just be the opposite of whatever the x value is. If the x value is -2, the y value is +2. If the x value is 5, the y value is -5. So anyway, that's the idea of it. Let's delete, let's get rid of the r's, because the idea is we're going to find our own idea of what those r's are. Let's find the, okay, so let's pretend like, this is answering the question now. Let's pretend like this is a center point, some x, -x, right? At some x here, and the y being the opposite of x. We need to find out, not find out this distance, but we need to compare this distance. If this is P2, I'll call this D2. And we need to find this distance here in terms of x as well. I'll call that D1. We need to make it so that D1 equals D2. D1 equals D2. But first, let's figure out how to write D1 and D2. Now, the way to do those is by using the distance formula. If you want to call it Pythagorean theorem, great. I generally do. I'm going to go more for distance formula here. Now, the distance of 1, we got to do this like the x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I can do it sort of like this. If my x2 is x minus x1, that's 0 quantity squared, plus y2 minus, oh, that's minus -3. So minus y1 quantity squared like that. And I really want to simplify this. I want to give this a simplified look. So I can say this is the square root of x minus 0 squared is also x squared, so x squared there. I'm not going to get deep into how I do this. You can expand on your own. But this is a perfect square trinomial that expands to x squared minus 6x plus 9. Like that. Again, that's an algebraic thing. My goal is not to show every part of this, but to solve the problem for you. So that's how that expands. And if I combine like terms there, I get 2x squared minus 6x plus 9. And I'm not going to dare do anything with this right now. This is a nice version of what I have here for D1 expressed in terms of x. I can also express D2 in terms of x as well, because both of these have x's there. We're finding the distance between, say, x and 4 and -x and 0. So I can do the same thing. I can make this like a square root of, and we can call this x2, like this. I can call x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now that D2 is going to be square root of, this expands to x squared minus 8x plus 16. And then -x minus 0 is -x. -x quantity squared is a positive x squared. So now these x squareds can combine right here, and that's also a 2x squared. So this says 2x squared minus 8x plus 16. So now I have two different expressions for the distances, which both represent radiuses of this circle. To the center at y, somewhere on the line y equals -x, hitting these 2 points, and these are supposed to be equal to each other. So I'm going to make D1 equal to D2 down below, and I'm going to make this all black now. I'll rewrite that, actually, let me do that really fast. I want to say D1 equals D2, but after this I'm going to make everything all black because I got to start moving terms over, and so I got to solve for x. And I haven't done the problem yet. I don't know what it is. Hopefully it's rational values. So I have no idea. It will be, because these each have 2x squareds on them. But I'm setting these two distances equal to each other, and I got to find what value of x makes this true. Now, if you haven't done this kind of thing before, what you want to do is square both sides and kind of get rid of these radicals. Because the radicals are isolated, we can get those square roots gone out of here, and that gives me 2x squared minus 6x plus 9, and here is 2x squared minus 8x plus 16. It's one of those things where in the answer itself, you want to make sure that nothing's extraneous in your solutions. We'll figure that out. If I subtract 2x squared from both sides, they go away, so those are gone. If I add 8x over here, I get 2x, and if I subtract 9 over here, I get 7. So 2x equals 7, x equals 3, excuse me, not 3 halves, 7 halves, 3.5. 7 halves would be that value. Now, the y value, remember, y equals -x, so y is -7 halves. I mean, straight up, that's it. If I'm on a point x comma -x, the y value is the opposite of x. So we're at 7 halves comma -7 halves, just like that. And that's it. No, I got to find the radius as well, and I got to write the equation. But that's 3.5 for x, -3.5 for y. And I have no way confirming this is the answer. I could find a graphing calculator, but I think everything I've done so far seems to be ideal with regard to those situations. And when I plug this in, 7 squared is 4. I don't think there's an issue when it comes to extraneous values on that either. None of those are, oh, plus 9. No, these are going to be fine. answers, nothing extraneous in that matter. Okay, so those are my x and my y, really my h and my k. Remember what these are. These are really h, let's do that, h and k, the two values that are going to be for the center. Now we still have to find r. Keep in mind, both of these, either of these would represent your radius, meaning if I substitute, you can't really see that h and k, meaning if I substitute 7/2 for x into either of these expressions, I'm going to get the same y value of, I guess, of -7, I'm going to get the same radius. I'm going to get the same value that represents the radius for either of these. It doesn't matter which one. It really doesn't. I'll just choose the d1 value. So d1 equals, I'm going to use 7/2 for x. Let's do square root of 2 times 7/2 squared minus 6 times 7/2 plus 9. Imagine me doing this over typing. Like, forget what you have to read with it. I'd have to write it. This is why I'm doing this way. So this is 2 times, and I've never done a problem like this. I've done problems of this ilk, like writing equations and stuff. Not like this. This is a pretty cool problem. 6 divided by 2 is 3, times 7 is 21, and plus 9 there. I got a 2. I squared the 7 and the 2 fourths. 49/2 there. Sorry, I got to work out this fraction stuff. So 49/2 there. Negative 21 plus 9 is negative 12. Negative 12 also means negative 20, 2 over 2. Negative 24 over 2. 49 minus 24 is 25. Oh, that's pretty good. So 25 over 2 is in the square root. But remember, this is your radius as well. I don't care what the radius is. I care what r squared is. So if r is the square root of 25 over 2, then r squared is 25 over 2. And I care only about that because that's what I'm going to use in my equation. I'm going to use h, k, and r squared. So my final result for this should be, let's do this a little thicker, x minus h, x minus 7/2, and that's also negative 3.5, quantity squared, plus y plus 7/2, because it's the opposite of the negative, quantity squared equals 25/2, that's r squared. That should be the equation there, which means you have a center at 3.5 comma negative 3.5, and your radius is, well, the square root of 25 over 2, like that. So actually, this area actually makes sense. That would be 3.5, negative 3. Actually, that makes a lot of sense because that's a little less than 4. I just made that up. But 3.5, a little less than 4, like that. And a little more than, yeah, that looks pretty good. So I'm going to take that for what it is. I'm going to trust that that's the answer there. Remember, 7/2 is 3.5. You can work it out that way. Okay, so to AXG005, I hope that video helped you. I'm sorry if it's late. Hopefully you still learned something from it. And I intend to do more of these. I get pretty busy overall, but I thought that this was a really good one to do because I knew it was something I couldn't type out. Well, take care, guys, and thank you for your first video entry in Ask Mr. Robinson. Take care and have a good day. I'll see you in the next one.